Hi everyone. Today we're going to study the chain rule. If f of u is differentiable at the point u equals g of x, and g of x is differentiable at x, then the composite function f composite g of x equals f of g of x is differentiable at x, and f composite g prime of x equals f prime of gx times g prime of x. In words, differentiate the outside function and evaluate it at the inside function left alone. Then multiply by the derivative of the inside function. Let's have example 1. Differentiate sine of the quantity x squared plus x with respect to x. Let us write the formula for the chain rule. So d over dx of sine of the quantity x squared plus x. We can see here that the sine is the outside function and the polynomial x squared plus x is the inside function. Using the pattern here, we write cosine of the quantity x squared plus x. The derivative of sine is cosine. And we copy the inside function as is. Then multiply by the derivative of this function x squared plus x. That's why we have here 2x plus 1. And the final answer is the quantity 2x plus 1 times the cosine of x squared plus x. Take note that this function here cannot be combined with this function x squared plus x because the 2x plus 1 is a polynomial function, while the x squared plus x is the angle for the cosine. This is our final answer. Let us see this example 2. Find f composite g prime at x equals 1. Given f of x equals x raised to 6 plus 1 and g of x equals square root of x. For our solution, let us show first that f composite g of x equals f of g of x. Let us substitute the value of g of x in here. So we have now on the right side f of the square root of x. Simplifying this f of square root of x, the square root of x raised to 6 plus 1. We can simplify this expression into x cubed plus 1. This time, we are ready to take the derivative of x cubed plus 1. So the f composite g prime of x equals 3x squared. This is the derivative of this polynomial function. Now, at x equals 1, we can show that f composite g prime of 1. This is equal to 3 times 1 square. This 1 square is simply 1. 1 times 3 is simply 3. This is our final answer. Example 3. Find y prime of y equals the quantity x cubed plus 4x minus 7 all raised to power 6. Let us write the formula for the chain rule. In here, take note that the outside function is the power function, that power 6, and the inside function is the polynomial function, this trinomial here. So for the derivative, we write like this. We have 6 times the quantity x cubed plus 4x minus 7. This trinomial is now raised to 5 times the derivative of the polynomial function. So we have 3x squared plus 4. This is our final answer. Let us have this example 4. Find the derivative of the function y equals 7 all over the quantity 2 plus 3x all raised to 2. At first, let us rewrite the function as y equals 7 times the quantity 2 plus 3x, and this is now raised to negative 2. Then let us write the formula for the chain rule. Let's take note again that the outside function is the power function, and the inside function is the polynomial function. Now, for the derivative, we will write like this. This big expression here corresponds to the f prime, while these 3 correspond to the derivative of the inner function, the g prime. Then let us simplify by multiplying the constants. So we have negative 42 times the quantity 2 plus 3x all raised to negative 3. Let us rationalize the negative exponent. So we have now this negative 42 all over the quantity 2 plus 3x all raised to 3. This is our final answer. We're going to study first and second derivatives of parametric equations. Let us first define parametric equation. A parametric equation defines a group of quantities as functions of one or more independent variables called parameters. For example, we have here a parametric equation. We have x equals 5t squared, y equals 2t plus 1. In this equation, we call t as the parameter. Let us go now to the first and second derivatives of parametric equations. If x equals x of t and y equals y of t are differentiable functions of x, and dx over dt is not equal to 0, then the first derivative dy over dx is given by dy over dx equals dy over dt. This is the derivative of the y function with respect to t, all over dx over dt. This is the derivative of the function x with respect to t. Now, the second derivative of the parametric equations is given by this equation. This is equal to 1 over dx over dt times d over dt of the first derivative dy over dx. In words, take the derivative of the first derivative with respect to x, then divide it by dx over dt, which is already found from the first derivative rule. Let us see example 1. Find the derivative of the parametric equation x equals at squared, y equals 2at at the point t equals 2. For our solution, we need the dx over dt, also the dy over dt. This is the derivative of this function with respect to t. So dx over dt equals 2at, while the dy over dt is the derivative of this y function with respect to t. This is now equal to 2a. Now, the derivative of parametric equation is now given here. So we have dy over dt all over dx over dt. Substituting the corresponding values, we have now the dy over dt to be this 2a, and the dx over dt is the 2at. We can see that there is a common in the numerator and denominator that we can cancel. That is the 2a. So the answer here is simplified into 1 over t. Now at t equals 2, let us substitute the value of t as 2 in here. So now dy over dx is equal to 1/2. This is our final answer. Let us see this example 2. Find the equation of the line tangent to the curve at the given point, and then find the second derivative of the parametric equation. The equations are x equals 2 cosine t and y equals 2 sine t at the point t equals pi over 4. For our solution, let us first start with the tangent line. We note that the dy over dx, or the first derivative at the given point, is the slope of the line. So now, with respect of the parametric equation, we need the dx over dt and the dy over dt. This dx over dt is equal to 2 times the derivative of this cosine t is negative sine t. We can simplify this into negative 2 sine t. Now dy over dt is the derivative of this function y. So we have now 2 times the derivative of sine t is cosine t. Next, our dy over dx, this is the first derivative, is equal to dy over dt all over dx over dt. Substituting the corresponding values, we have now this 2 cosine t all over negative 2 sine t. We can simplify here by cancelling the constants. Our final answer is negative cosine t over sine t. Now, at t is equal to pi over 4, let us substitute this value of t in here. By then, we can get the slope. So we have now the slope is equal to the negative of cosine pi over 4 all over sine of pi over 4. Substituting the corresponding values for cosine and sine of pi over 4, it is the same. So we have this negative 1 over square root of 2 all over 1 over square root of 2. we can see that the numerator and denominator are the same. So we can cancel this out into -1. The next thing we need is the point xy. We are going to evaluate the parametric function at t equals pi over 4. Let us copy the equations here again and substituting the value pi over 4 to the t. So we have x equals 2 cosine of pi over 4. And the y equals 2 sine of pi over 4. This cosine pi over 4, we had the value a while ago here. So we write 2 times 1 over square root of 2. We can simplify the product here into square root of 2. For the y, this is equal to 2 sine of pi over 4. This is equal to 2 times 1 over square root of 2. And this is equal to the square root of 2. So the point that we need is the square root of 2, comma, square root of 2. Now for the equation of line, we have this standard form, y minus y sub 1 equals m times the quantity x minus x sub 1. Substituting the corresponding values, we have the y minus square root of 2 equals, the m now becomes -1 times the quantity x minus square root of 2. Simplifying the right side, we have now this -x plus square root of 2. To simplify further this negative square root of 2, we are going to transpose on the right. But there is this positive square root of 2. Then later on, they will be combined. So our answer now becomes y equals -x plus 2 square root of 2. This is now our final answer. This is a tangent line. Let us copy this answer opposite the tangent line in here. Next, let us solve for the second derivative. For this formula, we need the values dx over dt is equal to -2 sine t. We were able to get this value a while ago. Also, the dy over dx, that is equal to negative cosine t over sine t. But wait a minute. The cosine t over sine t can be further simplified into negative cotangent t. Now, let us substitute these values in our second derivative formula. So we have now 1 over the dx over dt is this -2 sine t times d over dt of dy over dx. Taking the derivative of this, we have now the negative sign. Also, the derivative of cotangent t is negative cosecant square t. Now, negative and negative becomes positive. Also, we can see that we have a sine t here. This cosecant square t is related to the sine that we can take the reciprocal. So we have now this expression to be 1 over sine square t. There are sine functions in the denominators respectively. So we can combine them together. And this is now equal to negative 1 over 2 sine cube of t. This is our final answer. I hope you learned something from this video. See you again next time.